My name is Amshina Gleeker, and this is my Chem extra credit project. So for question 1, for the reaction N2 plus 3H2 to 2NH3, the change in entropy is less than 0 because there is a decrease in the number of gas molecules in the reaction. There are 4 moles on the reactant side, as it can be seen, and as there is 1 mole in N2 and then 3 moles in H2, which combine to form 2 moles of gas product of NH3. Because there is a decrease in gas molecules, the entropy decreases too, which causes the change in entropy to be negative. Therefore, change in entropy being less than 0 is true. So for the reaction above is also an exothermic reaction. Therefore, the change in enthalpy is less than 0, as the enthalpy is negative 92.4. Since the reaction is exothermic, it releases heat into the surroundings, and this increases the entropy of the surroundings. Therefore, the sign for the change in entropy is positive, of the surrounding is positive. The forward reaction is exothermic, as explained above, and according to Le Chatelier's principle, increasing the temperature will shift the reaction in the other direction to absorb heat. In this case, the reverse direction is the opposite direction. Therefore, increasing the temperature will cause the equilibrium constant to decrease. And then for part 3, in a spontaneous reaction, the triangle G has to be negative, as the relationship between those, like triangle G, the change in entropy, is given by the equation, as it can be seen. And then since the change in enthalpy is negative and so is the change in entropy, increasing the temperature will make the second part of the equation more positive. And after a certain point, the second part of the equation will be big enough that it can cancel out triangle H and make triangle G positive. This is when the reaction will become non-spontaneous. And this reaction will be spontaneous when the second part of the equation is not big enough. So the triangle G will be negative. And then for part C, this is my graph. So below the x-axis, when triangle G is less than 0, that's when the reaction will be spontaneous, as it will be negative, as I discussed in the question above. And then when it's above the x-axis, it will be non-spontaneous. And the red dot represents the triangle G when it's 0, so when it's at equilibrium. So for question 2, according to Le Chatelier's principle, when the particle pressure increases, the reactant gases of their equilibrium shift in direction that will reduce the pressure. So in the reaction N2 plus 3H2 to 2NH3, it will go in the forward direction compared to the reverse direction, as it will yield in fewer moles of gas. So the reaction will move in the forward direction. So for part 2 of question 2, part A, when the particle pressure of the reactants is increased, the reaction quotient will decrease, and when the reaction quotient is less than the equilibrium concentration, the reaction will move in the forward direction to reach equilibrium. For part 3, when the reaction spontaneously proceeds in the forward direction, the Gibbs free energy will be negative. And then for B, high temperatures and high pressures are optimal for this reaction, because high temperatures are optimal because even though the forward reaction is exothermic, high temperatures can overcome that high activation energy and break the triple bond that is between the two N molecules. And high pressures are optimal because high pressures are favored in the forward reaction, which in return reduces the number of gas molecules and increases the rate of the reaction by increasing the frequency of collisions. So for question 3, part A, we were given the graph as it can be seen. And to get the activation energy, I used Arrhenius equation and converted it to the point slope form, as it can be seen. As shown in my work, the graph provided was used because the slope was given in the graph, so I plugged that in, and R is a constant, so I also plugged that in and solved for the activation energy. However, to get the answer in kilojoules per mole, because it first gives you in joules per mole, I had to divide it by 1,000, and this yielded me an activation energy of 503.2 kilojoules per mole. And then for B, for question 3, a catalyst speeds a reaction by providing an alternate pathway that has a lower activation energy. This means that more reactant molecules have enough energy to overcome the energy barrier and form products, therefore increasing the reaction rate. And then for part 2, for the if I were to add a catalyst to the plot, it would lower the activation energy, and this would make the slope less negative or less steep, and can also cause the y-intercept to change. And then for question 4, to find the reaction quotient, since the particle pressures were given, I just plugged that into the equation and solved for the reaction quotient, and this yielded in a reaction quotient of 6.4 times 10 to the negative third, and the equilibrium constant was already given in the question itself, and then from because we got the reaction quotient, I found out that the reaction quotient was greater than the equilibrium concentration, and therefore this reaction will proceed spontaneously in the reverse direction. To find the equilibrium particle pressures of N2 and H2, I first set up the ICE table by plugging in all the initial values that were given in the question. And then, since it was moving in the forward direction, I added the x's to the reactants and subtracted them from the products. As the equilibrium particle pressure was given for NH3 in the question, I used that to solve for x, which yielded an x of 1.85, and then I plugged this x into the equilibrium concentration equations that I got from the ICE table, and then this yielded in N2 having an equilibrium particle pressure of 51.85 atm, and then H2 having an equilibrium particle pressure of 55.55 atm. Thank you.